Hi friends, welcome to the Unit 3 Day 1 notes. Here we're going to get an example 1, graphing from standard form. To graph from standard form, follow the steps over here off to the side. What we have is this equation, this function f of x equals 2x squared minus 8x plus 3. So we're going to find the x value of the vertex by using this formula, opposite b over 2a. Figure out what that is, first we have to denote, well, what's a, b, and c? In this case, a is 2, b is negative 8, and then c is 3. So if we're going to find the x value of the vertex by using opposite b over a, then we're going to have opposite of negative 8 all over 2 times a, which is 2. To simplify this, we have opposite of negative 8, so 8, over 4. That simplifies down to 2. This is the x value of our vertex. It also gives us the equation of the axis symmetry. Remember, quadratics, they can reflect, and they reflect over the axis symmetry. This is the x value, so to find the y value, we're going to plug in 2 back into our original equation. So we're going to take, in this case, f of 2 to find it. So f of 2 is 2 times 2x squared minus 8 times 2 plus 3. 2 squared is 4, so I have 2 times 4 minus 16 plus 3. You can multiply that. 8 minus 16 plus 3. 8 minus 16 is negative 8. Negative 8 plus 3 is negative 5. So my y value is negative 5. So my vertex is going to be at 2 comma negative 5. My axis of symmetry, which we abbreviate usually as AOS, is x equals positive 2. Note that it's a positive 2 and it's x equals. Remember, our axis symmetry is going to be an equation of a line. It says find the x and y intercepts. So remember, to find the x and y intercepts, you either plug in 0 for x or 0 for y. A good way to find the y-intercept is to plug in 0. This is very easy to look at in standard form because this becomes 0 and this becomes 0. What do I mean by that? So if I take f of 0, I'm going to have 2 times 0 squared minus 8 times 0 plus 3. These will zero out. 0 squared is 0 times 2 is 0 minus 0, so you end up with just 3. So we have a y-intercept of 0 comma 3. Let's go ahead and plug in some of these points here on this graph. So my vertex is at 2, negative 5. 1, 2, 3, 4, 5. So I'm going to plot these points and then graph. And then 0, 3, 1, 2, 3. Here we go. A lot of students will draw in the axis symmetry to help them count. That's perfectly fine. I'm using an erasable pen, and I want to show you that at the end, I do want to erase my axis symmetry. That is not part of the actual graph. That does not satisfy this. Remember, we're graphing all the points that satisfy this equation. So that's going to reflect over. So here, I can count. I have 2 spaces away from my axis symmetry, so then I need to go 2 spaces further out from that as well. To find your x values, your x-intercepts, you could solve for this. You could use the quadratic formula. That's one way to find the x-intercepts. So find x-intercepts. You could solve using the quadratic formula. You could factor. That's another way, if it's possible. Sometimes it's not possible to factor easily, and you have to use the quadratic formula. If there's no b term, then you could use the square root method. Or you could also complete the square. This list should look familiar, as these are all the ways that we found just different ways to rewrite functions from earlier. And you're going to see this again as we convert from each of these different forms. Let's see. I think the easiest would be to see if it factors first, go down that path, and then if it's not easily factorable, then to go into the quadratic formula. Looking at this, let's just check to see if it is factorable. So to check to see if something's factorable, I'm going to notate similarly how I did previously. So I'm just going to say, is it factorable? Factorable? Question mark. And so, again, 2x squared minus 8x plus 3. So here I have 1 and 2. Here I have 1 and 3. So can I notate these in a way that I'm going to be able to get a -8 here in the middle? Knowing that this is plus, I know that this would have to be a minus and a minus. And then these are going to be the last part, so I know it's going to be 1 and 3. First part, 1 and 2x. Let's see if that works. So that's -3, that's -5. Okay, that's not quite. Maybe if I move the 2, maybe that'll work, possibly. So if I have 2x here, 2 times -3, that's -6, minus 1 is -7. So, and I can't get any larger magnitude number. So this tells me right away, okay, it's not going to be easily factorable. I've checked all of my possible scenarios. So it's not easily factorable. Which leads us now to then falling back to the quadratic formula or completing the square. I'm more comfortable doing the quadratic formula just because I had it down from earlier. So I'm just going to go through that method. You could complete the square. We should end up with the same values. We're going to have to get decimal approximations. So I have opposite b, which we already know from earlier. Just kind of make a note here. Opposite b, so x equals opposite b plus or minus square root of b squared minus 4ac times 2 times 3 all over 2 times 2. So I'm going to do some simplifying here. X equals 8 plus or minus, so I'm going to have 64 minus 4 times 2 is 8, 8 times 3 is 24. Made my square root a little bit too long here. Benefit of erasing, all over 4. So I have x equals 8 plus or minus, looks like square root of 40, all over 4. Square root of 40, so if I wanted to check to see if 40 reduces, I'm going to do factor trees. So let's see, 4 I know is going to go in there, and that's a perfect square, so I can pull out 4, so I have square root of 4 times square root of 10, so that's going to be 2 square root of 10. So I have, oops, x equals, let's see, 8 plus or minus 2 square root of 10 all over 4. Now this could reduce. At this point, I see that I have a radical 10 here, so I'm going to grab my calculator, which I should always prepare before the video starts, but I always seem to forget that, since I'm going to get decimal approximations anyway. So this is going to be 8 plus 2 times square root of 10, and then divided by 4. So I'm going to get x is approximately 3.58, and then 8 minus 2 square root of 10 divided by 4, and x is approximately equal to 0.42. So that kind of tells me where they're going to be approximately. 3.58 is close to here, and then 0.42 is closer to here. So with that, now I have 5 points. I can graph this quadratic. One thing to note is your values with the A. A lot of students want to think A is slope. A is not slope. A is an example of how much you stretch. In a linear graph, the value that would be there is slope. It's not slope for any other type of graph, especially a quadratic. A talks about how much your rate of change or how much that vertical stretch is going to happen with this particular graph. I purposely put a point here and here because from this value, which is 1 away from your vertex, it is exactly 2 units away from that point. So this is that stretch by a factor of 2. Normally it would just be 1, but because it's a 2, it goes to that point. So that's your graph using the transformations of the A value. Also notice that this is a positive and it opens up. That matches what we have. And this looks like it stretches more vertically, which also matches what 2 is. We really digested this example. Join me in the next one as we go over graphing using a different method.